Hello, this is Tim from Tiger Astronomy, and in this short video I want to talk about test-driven development and why it's a good idea. Now, this is the code from the Digital Domeworks ASCOM driver, which I've recently rewritten. It was originally written in about 2006, and in the sort of 12 years since then, I've learned a lot of new software engineering techniques and I think upped my game somewhat. So I've rewritten the driver, partly because I now felt that the old code base was of rather poor quality and not really acceptable anymore. And I've written the whole thing using test-driven development. Now, I want to show you not really how to do test-driven development, but why it's a good thing and why in the maintenance phase of a project, which this project is now in, how having a unit test suite can really give you confidence to make changes and know that you haven't broken the rest of the code. So on the screen now, we have one of my tests. Now, I need to give a bit of background here. What's actually the change I need to make is it's been discovered in testing that if the shutter of the dome is closed and you instruct the shutter to close again, then the driver currently issues that command to the controller. The controller tries to do it and can't because the shutter's already closed. And sometimes it gets a bit confused by that. And about half the time, it will report a shutter error. So I need to change the driver so that if it sees the shutter is already closed, or open for that matter, and that command is issued again, it doesn't actually issue the command to the controller. So I've actually already done the closed side of things, and I'm currently working on the open commands. So here on the screen is a test I've already written, and I use a test framework called machine.specifications. It's actually a behavior-driven development framework, but I use it for test-driven development as well. And the basic format of these tests is you have a class, and the name of the class is sort of describes the situation you're in. So when shutter open received and shutter not open, then this inherits from a base context which sets up some things I need for the test. I won't go into the details of that. And then in a unit test, you have three phases. You have the arrange phase, you have the act phase, and you have the assert phase. So arrange sets up everything you need for the test. And then in machine.specifications, that takes the form of an establish clause. So ignore this funny lambda syntax. When you've been using this framework for a while, you don't even see those anymore. So this is establish context as these actions here, and I use the builder pattern to get my context ready. So we're starting up with a state machine initialized and ready using a fake communications channel, and we're starting with an indeterminate shutter. Now I won't go into the details of what that does because we're getting into the nitty-gritty of the code, and it's really a detail that you don't need to know. It's just the important thing is you can kind of read and understand what's going on. So we're starting with a state machine that's initialized and ready. It's using a fake communications channel, and the shutter state is indeterminate. Okay, so the build method here builds the context ready for the test. And then the because clause here is the act part of the unit test. So this issues controller.openShutter. So we exercise the code we want to test, and then the assert phase of the test are these it clauses. It should do something, it should do something else. And in each of those, you make it some sort of assertion about the state of the object under test. So it should be opening, test that controller shutter movement direction should equal shutter direction.opening, and it should send the open command it dives into the fake communications channel, into the send log, and tests that the open command has been sent to the channel. So these tests both currently pass, as you can see by the green markers here, and the test runner I'm using is a product called NCrunch, which is fully integrated with Visual Studio and is a fantastic product. In fact, I'm just going to pull another window in here, which is the risk progress bar. There we go. So this being all green tells me obviously all my tests are passing and there's nothing pending to run here. Now, okay, so let's look at the closed tests I wrote, because when everything was working before I started, and I wanted to write a test that pinned the current behavior of the code. So if we look at this test here, when shutter closed received and shutter not closed, this is the matching pair with shutter not open. It's a very, very similar test. And then just down below here, we've got when shutter closed received and shutter already closed. Now this tests the changed behavior that I was about to introduce. So in this test, we start with a closed shutter. We issue the close shutter command, and then we assert the shutter is not moving. We assert that it's still closed, and we assert that no commands were sent to the communication channel. Okay, so we need to do something similar to this for the open command. Now, as you can see, this is all passing, and that's because I've already implemented the code for this test. Okay, so now I've got a commented out test here for the similar case when the shutter is being open. So when shutter open received and shutter already open, so we'll be starting with an open shutter, and when shutter open received, now there's a mistake in this test I've just seen, so let's uncomment it. And we will just correct this mistake. So we're starting with an open shutter. We want to issue the open shutter command. Okay, open shutter. And you'll notice that NCrunch immediately runs the tests and tells me I've now got 2 failing tests. Okay, and notice I haven't even saved the code yet. This is how smart NCrunch is. It actually sucks the code out of the editor and runs all the unit tests as soon as you make any changes. So your test edit cycle is really, really quick. Excuse me, I've got a bit of a frog in my throat here. Okay, so it should not move. So we started with an open shutter. It should not move. So when we've completed our action, the shutter direction should be none because it's not going in either direction. It should be open, so we're testing that it's still open, and it should not send any commands, so we're verifying here that no command should be sent to the communications channel. So as you can see, 2 of these tests fail, and hovering over the failure icon, we see that expected none but was opening, so the shutter is in fact opening, and in this case the open GOPN command was sent to the communications channel. I'm sorry that's a bit small, but you can see it, I hope. Okay, so we now need to change the code to implement our new behavior. So if I look in my device controller code and we find open shutter, then you can see that the open shutter command is being passed through to the state machine regardless. Now, if you look at the close shutter command just below, I've already changed this, and you can see I put an if statement in there to test the existing thing, and then I log a warning if we're going to ignore the command. If we're going to do the command, I log that, and then I pass the command through. So we need to change open shutter in the same way. And notice that we've got failure icons right here in the code because ncrunch is telling me that there's a test that covers this code that has failed. And so, okay, let's recreate this if statement. So if the shutter position is already open, so the sensor state is open, okay, then we're going to skip the command. So the thing we want to do is return, okay, and I think that should be enough to make the test pass. So we'll just wait for ncrunch to finish running. The test it's still building. Here we go. The tests are running now, and the suspense, and there we go. We've gone green. So the tests are now all passing. Good. Now at this point, two things I can be fairly sure about. First of all, I've successfully implemented the feature I wanted to implement correctly. And secondly, I haven't done anything that breaks any of the rest of the code because I have quite a number of unit tests here against this code. I'm not sure of the exact number, but there are quite a few, and in several namespaces here. So there are lots of tests buried down here, and they are all still passing. So I can be reasonably confident at this point that my change has not broken the rest of the code. Now, I want to embellish this a bit with this nice log message. So I can just copy that one from there and paste it in here. And so we're ignoring actually the open shutter, ignoring open shutter request. And then when I actually do issue the command, I want to log that as well at the information level. So we'll just put that in here. Okay, and once again, ncrunch is running my tests. You can see over here there's an 85% risk I might have broken something based on test coverage. And the test runner is currently building the device interface. And once that has built, the test should run. And there they go. Notice it's only running the impacted tests because ncrunch does code coverage. It knows which tests cover which parts of the code. So if I change a piece of code, then it knows which tests it needs to rerun. And the risk of I've broken something slowly goes down until all the tests have run. We go green and we're okay. So we can be highly confident at this point that I haven't introduced a strange bug in another part of my code. So that's one of the benefits of unit testing and particularly test-driven development. It's people imagine that unit testing is a testing methodology. I don't think it is. I would argue that it's a software engineering technique that helps you write more robust code. So that's all for this time. I've been Tim Long from Tiger Astronomy. Thank you for watching, and goodbye.